Welcome to Mandalay Bay, a beautiful little waterfront community located on the coast of California, just north of Los Angeles. In the city of Oxnard, this wonderful community takes full advantage of its waterfront lifestyle. Everything from fishing and sailing off the coast, to cruising the harbor, to just plain admiring the view can be enjoyed year-round. Everyone gets in on the action. Junior sailors take lessons and have fun doing it. In addition to streets, they have channels, lots and lots of channels. And it seems like everyone has a dock, and every dock has a boat. As you can tell, the channels are at the center of the unique lifestyle in Mandalay Bay. For this reason, the city of Oxnard makes it a point to maintain the channels on a regular basis. This includes periodic dredging to remove sediments that flow into the bay through the storm drains that surround the bay. Because Mandalay Bay had not been dredged in many years, sediment had accumulated in many channels and significantly reduced the depth of water in many areas. To remedy this situation, the city of Oxnard made the decision to conduct a major dredging effort in the bay. Before starting work, however, the city needed to obtain all of the necessary environmental permits. In addition, the property owners requested that the dredging operation not damage their docks or make it impossible to use their boats for an extended period of time. The environmental permits issued for the dredging project placed tight limits on the quality of the dredged water. Because turbidity was sharply limited, it would be necessary to treat the water removed from the bay before it could be discharged back into the bay. In addition, the leakage of any fuels or oils from the dredge onto the water during operation was strictly prohibited.
I was approached by some environmental groups about the permit for the dredging project, and they were very concerned because of the description of the project was to this large centrifuge, and it scared everybody, and they thought it was going to be a big polluting nuisance on the farm field. It was going to be an ongoing problem, and I was a little concerned about it. And when the project finally came, we were all very relieved that it was a very quiet, environmentally friendly project, and that the centrifuge is hardly noticeable, just a small little device, and it posed no environmental problems.
After reviewing the technologies and bids provided by several dredging contractors, the city decided to go with Eveready Industrial Services from Edmonton, Alberta. Eveready's dredging technology and equipment met all of the tough environmental requirements and addressed all of the property owners' concerns.
I belong to the Channel Islands Waterfront Homeowners Association, and I'm on the board of directors, and my expertise is waterways, so that's what I'm in charge of. About 4 years ago, we knew that we needed our waterways dredged. The city was looking at a clamshell dredging process, and we were afraid that this would involve damage to our docks, possibly the boats. It was just too big, too bulky, too messy. And we looked into it and liked what we saw, and we started interviewing. And we're glad we discussed this and made up our mind on this process.
To understand how the technology works, let's start with the dredge. The Eveready technology is significantly different from conventional dredging. The dredge works quietly and efficiently using only electric motors. No diesel engines or hydraulic equipment are used, removing the possibility of spilling fuel or hydraulic oil into the water. A floating electrical cable carries power from the shore to the equipment. To control the movement of the dredge, a steel cable is used to guide the movement of the dredge through the water. As the dredge moves quietly along the cable, a controlled thickness of sediment is removed from the bottom of the channel using a suction cutter head. The dredge operator controls both the speed of the dredge as it moves along the guide cable and the depth of the cutter head, which is controlled by a precision hoist. As work progresses, the dredge operator receives updates on the depth of the tide and carefully adjusts the depth of the cutter head to maintain a constant cutting elevation. This proved to be particularly critical in Mandalay Bay, where the tide changes significantly during the day. Note that the dredge material is sucked up off the bottom of the channel by the dredge and pumped ashore in the dredge pipe that trails behind the dredge. This minimizes the spread of any contaminants that may be in the sediment into the open water of the channel. To dredge the channels without moving the docks, Eveready developed a unique dredging procedure. Special equipment is used to pump water over the bottom of the channel, pushing sediment out from under a dock into the channel. Using this approach, it was possible to remove sediment which had collected under the docks without moving the docks.
No, we didn't have to move our docks. They have a technique of blowing the soft material out with a pressure hose and then letting it settle, and then they come back and pick it up from a barge with a dredge cutter underneath it, and that's a pretty good thing too, because moving a dock would cost each homeowner probably $500 or $600.
This reduced the amount of time needed to dredge the channels and prevented damage to the docks.
But Eveready, as you well know, has a system that goes under the docks and blows the leaf and the various decaying material back into the center of the channel. Yeah. So it was a neat little tool that allowed for the docks not being moved. Right. In the early days, years ago, with the clamshell, we indeed had to move docks.
Right. Because the dredge is so quiet, it was able to operate from 8 a.m. until 10 p.m. without disturbing people living in waterfront homes next to where the dredge was working. This also reduced the time needed to complete the project. In addition, no single channel was closed for longer than 2 weeks.
They worked, it seemed like 16-hour days, and unless you saw them, you wouldn't know they were there. So they had lights on working at night, but there was no noise to speak of. So it was very, very quiet.
We were not affected in any way by noise. There was just no noise at all from the standpoint of the dredger.
Now that you know how the dredge works, let's take a look at the shore-based equipment. Dredged water and material picked up by the dredge is pumped from the dredge to the shore through a special pipeline. Part of the pipeline is floating, while most of it is submerged and rests on the bottom of the channel. The pipeline comes ashore and passes under the street to the shore-based treatment plant. To begin the treatment process, dredged material is discharged onto a shaker screen, which separates out the larger particles that would interfere with the treatment process. Dredged water and material that passes through the shaker screen enters the mix tanks, where a special water treatment aid called a flocculant is added. From the mixing tank, the dredged water and material is pumped into the 2 specially engineered dewatering centrifuges, which separate the water from solid material. The operation of the centrifuges, which is based on extensive experience, is optimized to maximize the separation of water and dredged solids. Solid material is discharged from the bottom of the centrifuges onto moving conveyor belts, which dump the material into a common loading hopper. Another conveyor carries material from the bottom of the hopper to the top of the material stockpile. As you can see, the processed sediment from the channels is relatively dry. Testing of the material shows a solid content of between 50 and 60%. By reducing the water content of the sediment, the volume of material requiring disposal is reduced, thereby saving on disposal and trucking costs. In addition to converting the dredged sediment into a high solids cake, the centrifuges produce a treated water that is remarkably free of solids. By adjusting the amount of flocculant added to dredged water before dewatering in the centrifuges, the clarity of the water is readily controlled. Weekly testing conducted over the course of the 8-month project did not detect one exceedance of the water quality standard in the environmental permit. Now that you've seen both the dredge and the treatment plant, we can summarize what you have learned. Let's start with the dredge. The dredge operates silently using only electric motors. Fuel or hydraulic oil spills are not possible. Sediment can be removed from below docks without moving them. The depth of the dredging is tightly controlled, even when working in tidal zones. The spread of any contaminants in the sediment is minimized because the dredge sucks the sediment off the bottom of the channel and pumps it ashore through a closed pipeline. Extended working hours are possible, even when working next to waterfront homes, because the operation is so quiet, reducing the time needed to complete the project.
We've had semi-dredging using clamshells here to remove some of the debris, but basically ineffective compared to Eveready and your project.
Turning to the shore-based treatment plant, we now know larger solids and trash is screened out of the dredge discharge before treatment begins. Water treatment aids are added to the dredged water and solids before dewatering begins. The centrifuges produce clear water that can be discharged back into the bay. The centrifuges also concentrate the sediment into a high solids paste thereby reducing the volume of material requiring disposal, which reduces both the trucking and disposal costs. To confirm that the dredging has been conducted properly and meets the contract requirements, we need to perform a post-dredging survey of the work. The best way to do this is to call upon the services of a licensed surveying firm with experience in underway surveys. The surveying data can be used to produce profiles or sections of the dredged channel. If a pre-dredging survey is also conducted, the data can be used to determine the volume of material removed. It all begins with collecting the data. The field crew uses a survey rod equipped with a GPS locator and a laser-operated transit located on the shore. To collect data, the survey rod is moved to a location in the channel where a bottom elevation is needed. When the desired location is reached, the rod is held upright in the water, with the rod resting on the bottom of the channel. A footpad at the bottom of the rod allows the rod to sit on the surface of the sediment without sinking in. The transit operator, located on shore at a predetermined elevation, aims the transit directly at the top of the survey rod. A computer inside the transit converts the data into a channel elevation at the location of the survey rod. By collecting elevations in a straight line along the bottom of the channel, a section drawing can be made. In addition to collecting data along a straight line, the survey crew can collect data over a wide area, making it possible to map the surface of the channel bottom. This information makes it possible to accurately calculate the volume of material removed by dredging. After the data has been collected, it is downloaded to a special CAD program that the CAD specialist can use to generate sections and surface contours. When the drawings are done, they are submitted to the client for review and approval. Note that the actual profile of the channel bottom can be easily compared to the contract requirement. This simplifies the approval process and provides a written record that the project was properly completed.
I was most impressed, and I was further impressed with the team of Eveready personnel. Being at my home, I could see them work. They were skilled, they were efficient, they all knew their job, they were very cordial, but particularly their work ethics were really fantastic.
That's great.
Most impressive, most impressive.
For more information, please check out our website at www.evereadyindustrial.com.